So all I have to write right now is this is equivalent to double equivalency. We write the definition, we have to write it. Okay, so for every epsilon greater than 0, there exists a delta also positive such that 0 is less than the absolute value. Can anyone, by looking at this and just mimic, to understand, to make sure that you understand what we're doing, what do I have to write in absolute value for this problem?
The equation.
Yes, which one?
5.
Careful. Delta has nothing to do with the function. Delta has only to do with x. Epsilon has to do with the function. The epsilon is with the function, and x is only with delta.
What's the importance of the zeros?
Which 0? These two?
Yeah, like
positive. This says positive. We have to say positive. It has to say positive. And this one, say it again.
Did you read out what the statement means again?
Yes. For every epsilon positive, there exists a delta positive such that the distance between x and 5 is less than delta, will imply, but what do I have to write here?
You write x minus 5?
Exactly. Exactly what we had. I didn't know that you're going to pick 20, so I have picked 5 here, but it's exactly the same. This will imply, and now we have to write this. The absolute value of the function minus the limit less than epsilon. How do I write this for our example? The function minus the limit in absolute value less than epsilon. What is the function in our case? Yes, go ahead.
Is it x minus 7?
The function minus the limit.
Is it f of x minus 5?
So would it be the 3 half x
minus
1 half?
Good. Minus the limit?
7.
Minus 7. Awesome. So this has to be the distance between the function and the limit. Good. So now how do we show this? And there are 2 steps to it. Here's the first step. We start here. This is the starting point. The absolute value of 3 halves x minus 1 half minus 7 less than epsilon. This is our starting point. What is the least common denominator? Good. So this one doesn't need anything. This one doesn't need anything. But does this one need to be multiplied by?
2.
Excellent. Awesome. Combine like terms. 3x minus
15.
Excellent. Good. Let's factor out. What do I factor out at the top?
3.
Excellent. What is left in parentheses?
X minus 5.
Excellent. Now, this is very important. This is the property of the absolute value. There are 2 properties of the absolute value. Here's one. The product equals the product of the absolute values. And the ratio, the same thing. I have to use these properties. I have to show at this step that I'm using these properties. So how do I do that? The absolute value of 3, the absolute value of x minus 5 over the absolute value of 2 less than epsilon. You can say, why do I need to write the absolute value of 3? I know it's 3. Why do I need to write the absolute value of 2 is absolute value? No, we have to use these properties first. Although we know that the absolute value of 3 is 3 and the absolute value of 2 is 2, we have to write this step. Then, yes, I'm going to write 3, and then the absolute value of x minus 5 and 2 and less than epsilon. What am I after? I'm after this. So if the left-hand side is only the absolute value of x, whatever I get here will be delta. So what should I do to solve this for the absolute value of x minus 5? What should I do to both sides to get the absolute value of x minus 5 on the left? Multiply both sides by?
2, then divide by 3.
Excellent. By comparison, can anyone give us delta?
2 epsilon over 3.
That's it. Okay, so what did we do? We showed that for any epsilon, we can find the corresponding delta that corresponds to that epsilon. If this is 0.1, if epsilon is 0.1, then delta would be 2 times 0.1 over 3. If epsilon is 1, then delta will be 2 over 3. If epsilon is 0.9, then delta will be 2 times 0.9 over 3. For every epsilon, each and every epsilon, I will find the corresponding delta. So for each and every epsilon positive, I will find the corresponding delta also positive, such that every time I choose x to be close to 5, how close? Delta close, smaller than delta, then the function value will be close enough to 6. How close? Epsilon close. Why is this mechanism possible? Because the limit exists. Otherwise, it will not be possible. So this was step 1. Also, step 2, I will not make you do anything else for step 2, but I need you to understand. You can say step 2. What are you talking about? When we prove a statement, we have to prove from left to right and from right to left because of the double equivalency. But all I would like you to write is, now show that delta equals 2 epsilon over 3 works by reversing the steps from above. That's it. You don't have to do the steps. That's it. Why this works, why I was able to find a delta for any epsilon, although we didn't even pick epsilon. But we found a generic delta that corresponds to this epsilon because the limit exists. Otherwise, the mechanism would not work. Any questions?
Yes.
Good.
So every time we have a problem like this, is our statement going to be set up like the way you wrote the situation before you solved it?
Yes.
Like that?
Yes, you have to write it in words. If you don't want to use symbols, it's fine. You have to write that for every epsilon positive, I will find a delta positive such that every time I pick x close enough to 5, but not equal to 5, then this will imply that the function value for that x, the distance between the function value for that x and the limit will be smaller than epsilon. This is way too much. It will take you half a page.
Okay, so and all of this solves for delta for that epsilon.
That's all we are trying to find. We're trying to show that for every epsilon, we find the corresponding delta. Why? Because the limit exists. So there are only 3 symbols. Let's work on one more problem and then move
I
on.
had
Yes?
a question about that one as well.
Yes, I'm ready.
So when we get a problem like that, are we going to be given the limit and like
Yes.
this equal to?
Yes. Yes.
Okay. And
So
then
this was, yes.
to do that.
Yes, this will be the limit. The limit as x approaches a from f of x equals L. So now let me also copy the general, so just give you the general formula or the with no values in it. So in general, the limit of f of x as x approaches a from either side is the limit. So that's the general one. So this will be for every epsilon greater than 0, I will find the corresponding delta greater than 0 such that every time I pick x close to a, not bigger than delta, this will always imply that the distance between f of x and the limit will be always less than epsilon. You either use these symbols or you have to write half a page because it's a lot of writing for that.
This might be a dumb question, but this is being recorded, right?
Yes, of course. And I have 10 other classes from before. You can go back to the other ones. They all have this explanation. Absolutely. And it's never a dumb question. So let's work on another problem. Let's choose another. I'm going to choose 17. And then let's move on. Limit as x approaches -2 from -2x plus 1 equals 5. After you work on the 3 problems, you're going to say, oh my goodness, this is the easiest topic so far. And it is. But right now, it still looks difficult. So can anyone tell us what to write? Give it a shot here. No one is supposed to know this from...
Every epsilon greater than 0, there exists delta.
Yes, corresponding to epsilon, I will find a positive delta. There will always exist corresponding to epsilon, corresponding delta, corresponding to epsilon, a positive number. Yes, such that.
Such that 0 is less than the absolute value of something, of the x minus 2,
Careful, it's minus 2.
x plus 2.
Correct. Is less than delta, which means every time I pick x close to -2, not further away than delta, close enough, okay? This will always imply that the function value of x, the distance between the function value at x and the limit, the distance, this is the distance between the function and the limit, must be less than epsilon. So what will be the function and the limit?
-2x plus 1 minus 5.
That's it. Remember, we start here and we want to obtain this. This is what I want. So number 1, -2x plus 1 minus 5 less than epsilon. What do I do inside? Now it's only algebra.
Simplify.
1 minus 5.
-2x. Yes,
Minus 4.
good. What do I do next? Inside the absolute value.
Separate it?
You mean factor, but what? I can't say,
Take out
oh. The absolute value of a plus b does not equal the absolute value of a plus the absolute value of b. So we cannot separate, not separate. This is not a product or a quotient. These are the only two properties. There is property for the product and a property for the ratio. We don't have any properties for the sum or difference.
You can factor out -2.
Yes, very good. What is left in parentheses?
X equals 2.
Good. We are close. We're close. Now this is a product. What do I write? Because it's a product.
The absolute value of -2 and the absolute value of x plus 2.
Brilliant. Thank you. What is the absolute value of -2?
2.
Awesome. What do I do next?
Divide by 2 on both sides.
Compare and tell me whether we found delta.
Delta equals epsilon over 2.
That's it. And in number 2, show that delta equals epsilon over 2 works by reversing the steps. Done. If you redo these problems a couple of times, it will become second nature. Promise. That's it. Yes, if we have a quadratic function that is more involved, if we have other types of functions, yes, but I'm only asking you linear functions, nothing else.
I think this was already asked, but for linear functions, this like the directions of the signs are always going to be the same, right? Like it's always going to be less than epsilon.
Of course. No matter what function we have, they will always be less. So the distance here has to be between f of x and the limit has to be less than epsilon, and the distance here between x and 5 has to be less than delta. So this is positive, this is positive, this is positive but not equal. That's why we use this symbol and not the equal symbol. Or if we forget about this, I'm giving you permission to use x to be 5, and you cannot. This cannot be 0, and this establishes that. The fact that we write this is greater than 0 and not equal to, we are specifically saying you cannot pick x to be 5, and we talked about that last week. So that's what this ensures, that you will never pick x to be 5, because the whole thing collapses. We are not allowed to use x equals 5, but you can say, but you plug it in. Yes, to see the type of limit. That's why we're plugging it in, and sometimes for polynomials it works. So this has to be positive, in other words, not 0, and the distance between x and 5 has to be less than delta, and the distance between the function and the limit has to be less than epsilon. So epsilon and delta are positive, everything else is less than delta, less than epsilon. I'm not sure whether that was the exact question. Was it the exact question?
Yeah.
Okay, perfect then. Other questions here?
Just to kind of like rehash what we
Yes.
did here, all we did was prove that the concept of a limit is real, right? Like
We-
that's what this is.
Yes, we only showed that this limit is 5 because for every epsilon, I was able to find the corresponding delta. If I cannot find for each and every on the planet, for each and every epsilon, if I cannot find a delta, then the limit does not exist. But the limit exists because for each epsilon, unknown, I was able to find the corresponding delta as epsilon over 2. Now you can say epsilon is 1. Okay, then delta is 1/2. Then you can say epsilon is 0.1. Of course, okay, then delta is 0.1 over 2. So for every number you pick as epsilon, you will be able to find a corresponding delta. Pick epsilon, I'll give you delta. Pick another epsilon, I'll give you delta. Why? Because the limit is indeed 5.
Is there ever a time where it makes sense to